Okay. So hello everyone. My name is Kunal, and I'm your mathematics tutor. And we are doing actually definite integration. And today is our the fifth lecture on it. And let me recap you. अभी तक हमने क्या क्या कर रखी हैं. So we actually deal with the what is definite integration, what is geometrical interpretation, and some property we look into it. And we already look into some property, and in yesterday class we actually deal with some important property there like king's rule, queen's rule, right? We go through it and we actually deal some problem based on like how to implement king's rule and how to implement queen's rule as well. So in the in yesterday class हमने ज्यादा question queen's rule पे तो नहीं कर पाए थे, but in today's class we actually first uh, deal with some question which has implementation of kings and queens rule as well in combination. So we look into it like how to implement or do and proceed the problem, and then we discuss some more property today, which is the property number third important property. These are these make our integrand very favorable to solve, right? So let me take the first question of today. So let's begin the with the question which based on Queen's rule. So let me give you the heading. So we are doing problem based on Queen's rule. In yesterday lecture, we already learned how to apply or implement the King's rule, and in today's we learn how to implement the Queen's rule and what some more properties today. So let's begin with the first problem of the day, which based on implementation of Queen's rule. So it is like we have to integrate from 0 to pi sine to the power 8x and cos to the power 5x. Right. So we know one thing like we actually already read in Wallis formula in our lecture number 2. If you don't remember, go and check it on. So what it explains sine to the power nx, 0 to pi and cos to the power mx. So we actually integrate these kind of function, but the limit are from 0 to pi by 2, right? And the here limit is from 0 to pi. And you know one thing which we already read in Queen's rule, like if we apply the Queen's rule, the limit becomes half, right? Right, the limits become half, and we need actually 0 to pi by 2, right? So we have to apply Queen's rule here. So let's apply Queen's rule here. So when we apply here, this is our I, which is from 0 to pi sine to the power 8x cos to the power 5x. So our when we apply the Queen's rule, it will be something like 0 to pi by 2. And what we write? Fx plus f of pi minus x, right? So sine to the power 8x. Let me read it. Pi minus x. Okay, so here we like pi minus x and cos to the power 5 pi minus. Right. I hope you'll all understand this, what I'm trying to say. So our I is equal to, we are integrating from 0 to pi by 2. And we have to write this sine to the power 8x cos to the power 5x. And sine of sine to the power 8 pi minus x, basically sine pi minus x is sine x. So it will be like sine to the power 8x, and the cos pi minus x is minus cos x. So minus cos x to the power 5 will be minus cos to the power 5x. If you look these both part, these are the same part with different signs. So both get cancelled, and we get I is equal to 0 to pi by 2, 0 dx. I missed dx here also. So what we get, the I is equal to 0. And in yesterday lecture, we already deal with this. Like if f of x is equal to minus f of 2a minus x, so our integration value is 0. And if f of x is equal to f of 2a minus x, So our integrand value is 2y. So here f of x is equal to minus f of 2 minus x. So the integrand value is 0. I hope you'll all understand this, what I'm trying to say, right? So its integration value is 0. How we apply? So let me show you here. It is like the Quinn's rule said if you're integrating from 0 to 2a fx dx, it's equal to integration of 0 from 0 to a f of x plus f of 2a minus x, right? And we do the same thing. Our 2a value is pi here, and when we apply and do some and use some basic trigonometric property, so we get to the result, which is of the form fx is equal to minus f of 2a minus x. So its value will be 0. Right? I hope you'll all understand this, what I'm trying to say. Let's move on to the second problem. With based on, like, you have to learn that how I implement the Quinn's rule in this problem, right? I just, like in King's rule, what I do, let me recall you. In King's rule, we just replace x by upper limit plus lower limit minus x, right? But in Quinn's rule, what I do, I not just replace x by something. I just write fx as f of x plus f of 2a minus x, and we do the half of the limit, right? So what are my first approach? This given integrand is the form sine to the power mx and cos to the power nx. So I think like Wallis formula is valid here. So I have to convert this limit to the pi by 2, because in Wallis integrand sine to the power mx cos to the power nx is integrating from 0 to pi by 2. So just I try to apply Quinn's rule here, and in Quinn's rule limit becomes half of the initial limit. Let's move on to the second problem, which something look like we are integrating from 0 to 2 pi. This time, look, we are integrating from 0 to 2 pi, right? And our again function or integrand look like sine square x dot cos to the power 4x and dx. Okay. Now, look at here. This integrand is also of a form like sine to the power mx, cos to the power nx, dx, and from 0 to some limit like star limit, right? So we can also apply Wallis here, but for Wallis, we know that the star value is pi by 2, right? So you have to apply Quinn's rule here, because in Quinn's rule, its value become the limit value become half of initial. So applying Quinn's rule here, what we get, this is our I. From we are integrating from 0 to 2 pi sine square x cos to the power 4x plus what I have to, let me raise it here first. Okay, so what is dx? What its value is equal to? Its value is equal to from 0 to pi f of x. So our f of x is sine square x cos to the power 4x plus f of 2a minus x, right? So it will be like sine square 2 pi minus x cos to the power 4 2 pi minus x. And the both values, this value is negative, but this square makes it positive. Like sine of 2 pi minus x is negative, right? It's give the negative value because it lies in this coordinate, this quadrant, and in this quadrant sine value is negative, but square makes it positive. So what we get, we are integrating from 0 to pi sine square x cos to the power 4x plus sine square x cos to the power 4x. And if you observe that the both function are same, so we can add this function and we can write 2 from 0 to pi sine square x cos to the power 4x dx. Now, we can again apply the Kunz rule here, because this again function is the form sine to the power mx and cos to the power nx. So if our main target is to apply formula here. And for Wallis, our limit is varying from 0 to pi by 2. So what do? Again, apply Quinn's rule here. Because in Quinn's rule, limit becomes half of the initial. So again, applying Quinn's rule here. Quinn's rule here. So what we get actually, our I is equal to 2 from 0 to pi sine square x cos to the power 4x dx. So we can write this function as we are integrating from 0 to pi by 2 f of x, which is like that. And then I have to write, let me read it here. Okay. And then I have to write plus f of 2a minus x. So here 2a value is pi. So it will be like sine square pi minus x and cos to the power 4 pi minus x. We know that the value of cos pi minus x is negative, but the power is even. So it again become positive, right? So 0 to pi by 2 sine square x cos to the power 4x plus this value is same sine square x and cos to the power 4x 4 pi minus x is negative, but here the power is even, so it can be converted and write it into same way. And if you observe that again both was same, so what we can write here, 4 into from we are integrating from 0 to pi by 2 sine square x cos to the power 4x dx. Now applying Wallis theorem here and applying Wallis because now we get the favorable limit, right? We are integrating from 0 to pi by 2 and our integrand look like sine to the power mx dot cos to the power nx. So now applying the Wallis formula here. So from Wallis formula, what we get? 4 into like first we have to add this power. So it look like 6 and start subtracting 2 in it. Okay, इसमें से दो subtract कर दो. So 6 into 4 into 2. And what this power is 2. So we have to write, subtract it from 1 and then we have to write 1. And what is power? 4. So subtract minus 1 from here. So we will get 3 and then start subtracting 2 here. And so the both power is even. So what I have to multiply? Pi by 2. If you didn't get that, go to the lecture number 2 and watch the Wallis formula section. So you understand what I'm doing here. So when we solve this, what we get? This get cancelled, this get cancelled. So we get pi by 8. So this is our final answer. Right. I hope we'll all understand this, what I'm trying to do. So this is the way actually to solve our problem. Okay. Now, so you have to take an idea like how I have to approach the integrand. So if you look this problem, we are applying 2 times Quinn's rule here, right? 2 times Quinn's rule here. 1 times we applying for converting from the limit 2 pi to pi, and then we are again applying Quinn's rule to convert the limit from upper limit from pi to pi by 2. So this problem is based on application or implementation of Quinn's rule in a consecutive manner. Okay, now let's move on to the third problem, which something look like complex. So you have to learn like we can apply Quinn's rule many times as according to the question asked, right? जैसा question की ask है उसके according कभी कभी ऐसा भी होगा कि like you have to apply kings first, then apply queens, then again apply king, right? So you have to go through like that kind of problem. So let me take in the third problem, which I think based on that as well. Okay. So let me write it here. So it will be like, okay, now, so there's the fourth problem. It's something look like we have to find the integration of 0 to pi and sine of 12x divided by sine of x and dx. Right. So what I have to do here? So let's first apply here King's rule, right? So if we apply King's rule here, so what King's rule says, just replace x by upper limit plus lower limit minus x. So just replace x by pi minus x. So what we get? We are integrating. This is our I sine of 12x by sine of x dx. And what I have to do, I have to just write 0 to pi and I have to just write 12 pi minus x and divided by sine of pi minus x. I hope you'll all understand this, what I'm trying to say. It is equal to dx. And when we write that, so we get sine of 12 pi minus 12x and sine of pi minus x. And we know that this is the even. This term is lies in fourth quadrant, right? Because 12 pi is lie on this line and we are subtracting something from there. So we get on the fourth quadrant. And in fourth quadrant, value of sine is negative. Value of sine is negative. I hope you'll know that after go to school rule, right? There is the all values positive, right? After college, after school to college, right? There is a school. So here sine is positive. There is t. So your tan value, tan and cot value is positive, and here is college. So it will like cos and sec value is positive. So there the value of sine will get negative. So we'll get 0 to pi minus sine of 12x by sine of x. So what do you get from here? This value is like I is equal to minus I because this value is actually our I, right? So when we take that side, what we get? 2y is equal to 0. So I is equal to 0, right? This is the one way we get from King's rule. Now try to apply Queen's rule here and let's check what's is happening. Actually, same thing gonna happen here also. So let me do here for you. Like I is equal to here like 0 to pi from this time. This problem is solved first by King's rule. And now I am again applying Queen's rule here to like look what is the result we get. Do we get same result or some different? Actually, same result we get, but try to check ounce, right? So sine of 12x divided by sine of x and dx. So let's applying Queen's rule here. So when did we apply the Queen's rule here? What will we get? We get actually uh, I is equal to our 0 to pi sine of 12x sine of 12x by sine of x dx is equal to from 0 to pi by 2 f of x. So I just write f of x and then plus f of 2a minus x. So do like f of 12, what I have to do? Pi minus x, right? By sine of pi minus x. Because it will be written as 2a minus x. And here the value of 2a is pi. I just do that. So what we get? We are integrating from 0 to pi by 2 sine of 12x by sine of x plus this value is like what? Minus sine of 12x. Because it's same now, pi even power minus even. So again, we get into the fourth coordinate divided by sine of x. And these both value, same value, but with opposite sign. So what we get here? We get cancelled and we get integration value is 0. Right? So by kings and queens, we get the same value. Right? Okay. Now, now let's move on to the last problem, which based on queens, and then we move to the what property. Okay. So this problem is last problem which based on queens rule. So it's something look like Let me write it here. What is it? Uh, okay, so let's take the problem log 1 this time. Okay, so we have to integrate from 0 to 1, and our function look like ln of 1 by x minus 1 dx. Right, we have to integrate this. So now what I have to do, let's apply kings or queens, whatever you want. Because if you apply the queens rule, I think it will be easy or tough. Let's apply kings first, the basic kings first. Let's apply the kings rule here, right? So if we apply the kings rule here, what I get, I have to just replace x by upper limit, which is 1, lower limit, which is 0, minus x. So I have to just replace x by 1 minus x, right? So let's solve this problem applying king's rule here. Okay. So we are integrating from 0 to 1. Remember one thing, in king's rule, our limit doesn't vary, but when you apply the queen's rule, our limit become half of the initial limits. So that's saying that you have to uh, get in your mind. So what we do, we have to just replace x by 1 minus x minus 1. Do we get something from here or nothing? Okay, whatever. Let's go through it. So 0 to 1 log of 1 minus x, 1 minus x. So what we get from here? We are integrating from 0 to 1 log of, when we solve this, we get x by 1 minus x, right? X by 1 minus x. Okay. And we can write it as like 0 to 1 if we apply the basic log property. So we can take minus 1 and we do like 1 minus x by x. We can do it, right? And it will be like minus 1, 0 to 1 ln 1 by x minus 1, right? And these both values, let me write here dx. So this is actually is equal to minus I. That means I is equal to minus I. So 2y is equal to 0. So we get I is equal to 0 here, right? So again, the value of integration is 0. I hope you'll all understand this. So we, in today's question, we get lots of 0, right? This problem also integration is 0. In this problem also integration is 0. Oh, finally we get a non-zero. Nice. Okay, oh, in this also 0. So you have to check, right? Like if f of x is equal to f of 2a minus x, actually minus, so we get integration 0. That's the fact, right? So now let's move on to the next property, right? Which is actually it is also known as even odd property. So let's go through it. Okay. This is our property. Let me first. So I hope you'll all understand that how to implement the kings and the queens rule. It is very much important for definite part, right? Because most of the problem gets solved by these two property. Now let's go on to the third property, which is known by like even odd rule, right? It's called as even odd rule. Why it is called? आपको समझ में आ जाएंगी. तो सबसे पहले इस रूल को बताने से पहले मैं आपको एक चीज बता देता हूँ. What is even function? Anyone? If someone asks you what is even function, so what is even function? Let me define you. Actually function chapter में आपने पढ़ रखा होगा, but let me recall you अगर आपको ध्यान नहीं आ रहा हो. So what is even function? And what is odd function? So even function is something like fx is equal to f of minus x. That means if like cos x, if our function is cos x, so if you replace x by minus x, like cos of x is equal to cos of minus x, right? This both function is same, like fx is equal to f of minus x, right? So this is known as even function. And the second is if fx is equal to minus f of minus x. That means if fx is equal to sine x. And so f of minus x we do what we get sine of minus x. And this is equal to minus of sine x. Right? So fx is equal to minus of fx, right? So this is the basic definition of even or odd function. So why this property is known as even odd rule? You're gonna learn in some time. Let me write the property first. Okay, so our property is something look like if we are integrating a function from minus a to plus a f of x dx. So we can write this function as from 0 to a and then f of x plus f of minus x dx. Right. Now, here again it becomes as into a two case. What if our function is even, right? What if fx is even? क्या होगा अगर अपना फंक्शन इवन हो तो व्हाट इज एन इवन फंक्शन fx is equal to f of minus मतलब both are equal, so our integrand look like we are integrating from 0 to a 2 times of fx dx because both are equal na. And what if our function is odd function? So in odd function, what we know, f of x is equal to minus f of minus x, right? So f of x is equal to minus f of minus x, so both will get cancelled, so we get 0, right? So this is our actually property. I hope you'll all understand this. So let me try to prove it, right? Our property. So first make it in a box. Now what you have to do actually, okay. Now let's go through its proof. Like, how to prove it, and then we again learn how to implement this property for given integral. Like, so there is a condition like on implementing this property, we have to like if we are integrating from minus a to a, this is the necessary. Like x varies from so minus a to a value, not like which is like minus 2 to 2. ऐसा नहीं कर सकते हैं कि we are integrating from minus 3 to 2. तो ये property apply नहीं होगा. But this is very sensitive property. Like kings and queens rule क्या था कि कैसा भी कुछ भी दिया हो, just apply कर दो. It will valid. But this property odd even property is only valid if we are integrating a function from minus a to plus a. Like minus 3 to 2, we can't apply this property. We have to break and then apply, like we are integrating from minus 2 to 2 only. वो implement कैसे करते हैं? When we discuss problem in it, then we actually understand what I'm trying to say. Let's move to its proof. So the proof is like, okay, what I have to do, let me write our given integrand, right? So our given integrand like minus a to a f of x dx, right? So what we can do, we can write here, we can break this into this form like minus a to 0 because there's a in first lecture I told you like function should be continuous in like if I'm integrating this function from minus a to a, so in minus a to a the function should be continuous. So we can break this into minus a to 0, and then we are integrating this function from 0 to a, right? Because function is continuous, so we can write it into this form. We actually already learned this in lecture number 1. So if you not understand it, so go through the lecture number 1. So you will definitely get my point, what I'm trying to say. This is my first definition. The function should be, if we are integrating any integrand from a to b, so the integrand must be continuous in a to b. So what you have to do, this is this as equation number 1. So what you have to do, let's suppose this whole function as uh, x is equal to minus t. So what do we get? Let me try to write here. So there will be like a2's from like we substituting x is equal to minus t. So our limit also varies because now we are integrating in terms of dt. Like dx is equal to minus dt, na, if we are differentiating this. So when we look through the limit variation, so in limit variation, when x is equal to minus a, our t is equal to a, and when x is equal to 0, our t value is also 0. So our integrand like minus a to 0 fx dx will be something look like from t to 0 f of minus t, and there will be like minus of dt. I hope you all get my point, what I'm trying to say. And we can write this by using the property which I taught you in first lecture. If we inverse the limit, like if we are doing from 0 to 2, so we'll get f of minus t dt. Right? I hope we can write it into this form. Now, uh, so what we get, we are integrating from minus a to a fx dx, and is equal to, we can write in place of this, we can write it this. So let's try to write here. We are integrating from 0 to t f of minus t dt plus 0 to a and f of what? F of x dx. So the x is actually t is variable here and x is also variable. So we can interchange the variable. We get the same thing. So again, apply t is equal to x. Okay, so what we get, f of minus x, and limit varies from 0 to a and plus 0 to a and f of x dx, right? So what we get from here, we get like we are integrating from 0 to a f of x plus f of minus x and dx. So this is our proof, which is, I think it's easy. So I hope you'll all understand this, what I'm trying to say, right? If you didn't get, let me write it here, what I'm trying to say. What I do here, I just write this function, f of x, uh, f of x from integer from minus a to a. Just write it from minus a to 0 f of x dx. And we just broke it into two parts, one from minus a to 0 and one from 0 to a. And then again, I substitute the value of x is equal to minus t. So our dx value will something look like minus dt. And then we use the limit variation concept. So our limit varies from 0 a to 0. And then I use this some basic property of definite integration, and we reach to the final proof. Let's move on to the problem, like how to implement this. Okay. Okay. So our problem which look like so. Okay. So let's try to integrate this. So now we are doing problem based on even odd rule. Basically, we learn how to implement this or nothing, right? We have to just learn how to implement this theorem or property in problems. Let me try to write it here. Okay, so it's something look like our first problem is example one. But something look like we have to integrate from -2 to 2 log of 3 plus x divided by 3 minus x dx. Right, we have to integrate like that. Okay, so if you look here, limit varies from -a to a. If we take a as 2, so it varies from -a to a. So we can apply, देखो जब भी तुम्हें दिखे ना कि -a to a लिमिट जा रही है, then try to use the odd even rule. Otherwise odd even rule लगाना नहीं. Otherwise go through the King's rule, Queen's rule. ये वो सब जगह valid है. King's rule and Queen's rule are valid everywhere. बट इवन ऑड रूल की कंडीशन होती है कि इसमें लिमिट जो है वो -a to +a ही वैरी होना चाहिए. और यहाँ गिवन क्वेश्चन में वैरीज कर रहा लाइक है ना -a to a. So we can apply here our even odd rule. So let's apply here, applying even and odd rule, whatever it's called. So what I get, right? So let me write here. Okay. So we have to integrate from -2 to 2. Our function look like 3 plus x by 3 of minus x dx. So we have to write like, if we apply the odd even rule, it will be like 0 to 2 f of x. So our f of x is 3 plus x by 3 minus x and plus f of minus x. So we have to replace x by minus x. So 3 minus x by 3 plus x, right? I hope you'll all understand this, what I'm trying to say. And so it will be like we are integrating from 0 to 2 ln 3 plus x by 3 minus x. And if you look at here, if we apply some basic trigonometric logarithmic rules, property, basically basic property. So if we take minus outside the, so what we get ln, this will get inverse, right? Like I'm trying to say like ln 1 by fx is equal to minus ln of fx. I'm using this concept. So it will be like 3 plus x by 3 minus x. And if you look that, this both will same. So it will cancel. And we get 0 to 2 integration 0 dx. So we get the final integration value as 0. Right. So this is my integral value. Is 0. It's simple. Why it is 0? Because their fx is equal to f of minus x. Because the function is odd function. Minus, right? Because function is odd function. So our integral value is 0. So now what you have to do, you have to first check is our function odd or even. If odd function, then write the integral value directly 0. Don't solve this kind of thing. So let me show you how to do what I'm trying to say. Like let us suppose the next problem, right? So our next problem is something look like question number 2. So we are integrating from -3 to 3. Okay, look at here, -a to a. So we can apply even odd rule here. And our function look like 4 to the power x divided by 4 to the power x plus 4 to the power minus x dx. I hope you'll all understand this, what I'm trying to say. So let's apply here. First you have to check. पहले check कर लेते हैं कि function odd है या even है. So our fx is equal to क्या है? 4 to the power x by 4 to the power x plus 4 to the power minus x. क्या सीखा हमने? अगर फंक्शन ऑड आ जाता है सो डायरेक्टली राइट इंटीग्रेंड वैल्यू इज 0. f of minus x निकालते हैं. So we get 4 to the power minus x, 4 to the power minus x plus 4 to the power x. So if we solve this problem, what we get? 4 to the power minus x plus 4 to the power x and 1 by 4 to the power x. We didn't get like f of x is equal to minus f of x, minus f of minus x, right? हमें ऐसा कुछ मिला नहीं, right? So if we didn't get like this function is not an odd function. So this function is not an odd function. So we have to go through the even odd rule. So even odd rule अपन लगा सकते हैं. So let's apply the even odd. Uh, अगर odd function होता, so we directly write the I value 0. But this function is not odd function, so we have to apply the even odd rule. So when we are applying the even odd rule, so what we get? I is equal to what is given? Minus 3 to 3, 4 to the power x by 4 to the power x plus 4 to the power minus x dx. Right. And then I have to write from, we have to integrate from 0 to 3 and f of x plus f of minus x, right? So 4 to the power minus x by 4 to the power minus x plus 4 to the power x dx. You have to do nothing. You have to just take the LCM. So I think it will be easy way. So we get that, and we in denominator we also get the same function, right? And it both get cancelled. So we get dx integration. And when we integrate we get x. We have to integrate from 0 to 3. Insert the upper and lower limit. So we get the answer value. Sorry. The value of the integrand is 3. I hope you'll all understand this, what I'm trying to say. So अगर कहीं पे भी इंटीग्रेंट आपको दी हुई हो, ठीक है, कहीं भी इंटीग्रेंट दी हुई हो और इस तरीके से लिमिट को ध्यान देना है. लिमिट अगर -a to a दिया हुआ है, सो वी कैन अप्लाई ऑड इवन फंक्शन. सो स्टार्टिंग से ही लगा नहीं देना है, पहले चेक कर लो फंक्शन ऑड है या इवन है. चेक करने का रूल पता ही है. और अगर फंक्शन ऑड हुआ देन डायरेक्टली राइट द वैल्यू ऑफ इंटीग्रेशन इज 0. सॉल्व भी करने की जरूरत नहीं, राइट. इट इज द बेस्ट ट्रिक टू write the value of integrand. Just check the function is odd or even. If the function is odd, write the value, integrand value 0. And if the function is even, so solve it. है ना, वे तो पता ही है हमने कैसे सॉल्व करनी है. So let's move on to the next problem. Something look like, okay. So I guess this is our problem number 3rd. So it is like we have to integrate from -2 pi to 2 pi. And our function is cos to the power 7x dx. What is our function? Cos to the power 7x dx. So let's check first. Our fx value is cos to the power 7x. So when we do f of minus x, cos to the power 7 minus x, and we know that in cos of x is equal to cos of minus x. So we get the same value. Oh, so we get the f of x is equal to f of minus x. That means our function is even function. Function is even function. So we have to apply here the what's the odd even rule. So applying the odd even rule here. So what did we get? Actually, we have to take from 0 to -2 pi to 2 pi cos to the power 7x dx. So what do we get? We are integrating from 0 to 2 pi cos to the power 7x f of x and plus f of minus x, right? So both value will be same. Now we get 0 to 2 pi 2 into cos to the power 7x dx, right? Now we cannot apply the further odd even rule because our limit is not varying from -a to a now. Now our limit is varying from 0 to 2 pi. And the function is of type like cos to the power nx, cos to the power nx dx, whatever the power is odd or anything. So our new approach is to solve this problem is we have to go through the Wallis formula. But there is a condition for Wallis formula. When we apply, the limit should be vary from 0 to pi by 2. And you know one thing like how to half the limit of initial. So we have to apply Quinn's rule here. So let's apply the Quinn's rule here. So what we get, let's try to see. So now our integrand is something look like 2 into 0 to 2 pi. We are integrating cos to the power 7x dx. So when we apply the Quinn's rule here, look, हमें दिख गया कि ये फॉर्म इस तरीके की है एंड वी नो दैट कि बॉलिस फॉर्मूले से इजी से सॉल्व होगा but our limit is not supporting to apply the Wallis formula at this stage. इस स्टेप पे Wallis formula लगाने को satisfy नहीं कर रहा है क्योंकि the limit should be 0 to pi by 2. If I want to apply the Wallis formula here, our limit should be equal to 0 to pi by 2. But here our limit is 0 to 2 pi. So this step doesn't allow me to apply the Wallis. So we have to convert this limit into 0 to pi by 2. And there's only one way to do the limit half, which is actually is Quinn's formula. So let's apply the Quinn's rule. Applying Quinn's rule here. Oh, let me write it into good way what I'm doing. Applying Quinn's rule. Quinn's rule here. Okay, I have to apply the Quinn's rule here. So let me write here. So our integrand value is from 2 into 0 to 2 pi cos to the power 7x. So it will be equal to, we are 2 into 0 to pi and then cos to the power 7x dx and plus cos to the power 7 2 pi minus x, right? So both values same. So it will be like 4 into 0 to pi cos to the power 7x dx, right? Now again applying the Quinn's rule because we need the limit from 0 to pi by 2. Again apply Quinn's rule here. So let me write here again. Applying Quinn's rule here. So what I get, our I values now look like we are 0 to pi cos to the power 7x dx. So it will be like 4 into 0 to pi by 2 cos to the power 7x dx f of x, and then I have to write cos of 7 pi minus x. Oh, look at here. This value is nothing but minus cos to the power 7x because this value is lies in second quadrant. Pi minus x. What I'm doing. Let me write in a clear way here. This value is actually lie in the second quadrant, pi minus x. And the both value is same with opposite sign. So both get cancelled. So our I is like 4, 0 to pi by 2, 0 dx. Like I value is 0. So if you look at this question, our integrand value is 0, by the way. So if you look at this question, this is not a single step question. This is not the single step question. This is not the single step question, right? What I am trying to do, this is not a single step question. What I'm trying to do, I am first applying the odd even rule here, right? I am first applying the odd even rule here. Look at where it is. Okay, I first apply the odd even rule here. Then I apply the Quinn's rule, and then I again applying the Quinn's rule, and then we get the final answer as 0. So this is the multi-step question, right? Actually, it is easy question, but it is a multi-step question. It takes 2 to 3 minutes to solve, right? कैसे कैसे करनी है तो वो 2 से 3 मिनट ले लेता हूँ अगर सही से करनी है तो. Now let's move on to the today's last problem, which is actually a good problem. And then in tomorrow class, we will actually deal with some more property and problem as well. So let me write here the question. So our what's number is, I think, fourth number. So I have to integrate a function from -2 to 2. And our function look like x cube f of x plus x f double dash of x plus 2 dx. Okay, so this is our given integrand. This is our given integrand. So, and the limit also varies from -2 to 2. So we can apply here odd even rule because it's supporting that our limit varies from -a to a. So we can apply here the odd even rule, right? We can apply the odd even. So what I have to do, first check our given function f of x is like x cube fx. What happened to the pen? Okay, x cube fx plus x of f double dash of x plus 2. So what is f of minus x? So let me try to first check is the given function is odd or even. So put the minus x in place of x. We get minus fx cube minus f of minus x plus minus x and f double dash of minus x plus 2. And we know that the constant function is an odd function, right? Okay. So if you notice here, what we get, f of minus x is equal to, if we take minus common, so what we get? We get actually x cube f of minus x plus x f double dash of minus x. And this is an constant, so it will be an odd function, so nothing to worry about. So there's like f of x is equal to minus f of minus x, right? Because this whole function is nothing but f of x. So we can write it into like f of x is equal to minus of fx. Or if you multiply, these both are same now. So f of x is equal to f of minus x. So what I'm trying to say is this function is odd function. So we don't have to solve it. We can directly write this integration value is 0 because function is odd function. So what I'm trying to say, first try to check if the limit varies from minus a to a, first try to check the given function is odd or even function. So if you do so, if the function is odd, you can directly write I is equal to 0. If the function is even, then you have to proceed and follow the steps, whatever I taught you. I hope these things are clear to you. So let me recap what I today taught you. So I today taught you how to implement the problem based on Quinn's rule and King's Quinn's combination and Quinn's in consecutive steps, and then third property, which is even odd rule, and then how to implement the third property, and then what we learned, and how to implement the even odd rule with Quinn's rule, with consecutively Quinn's rule, King's rule, right? So तीनों property को mix करके भी मैंने problem बताया, like if you go through this problem, so we first apply this problem. We first apply the even odd rule here, and then we apply the Quinn's rule here. So it is a complete mixture of all of the three property which we read till now. So these are some problem, and then we discuss some more problem which based on the property third. It is very sensitive property because limit should be varies from minus a to a. अगर कुछ और यहाँ पे limit होगी, so we can't apply the even odd rule. Okay, then we have to look into some different approach, which we will discuss in tomorrow's lecture. Okay, and we discuss some more property and more implementation, right? And then we learn some sum of infinite series, like how to which are form like limit and tending to infinity, and something written in terms of 1 plus r by n, whatever, something r by n and 1 by n. So how to convert this summation into integration. We learn this thing in this definite chapter. So in tomorrow's or I think next after tomorrow lecture. So these things are left, which is very important for JEE main and JEE advanced things of purpose. So we will deal with it. Don't worry. So that's all for today's lecture. Thank you. Thank you very much. And try to practice the question which based on Quinn's rule, even odd rule, and the King's rule. These are the basic property. So, okay. We will meet in tomorrow's lecture. Thank you.